grab my light. Oh, I totally forgot to do something in the Weekly Space Hangout. I wonder if it's still appropriate.
What did you forget to do?
I will show you in a second.
Okay.
So this is our light that we use. And they're great.
Yeah.
So I can turn
You
it
don't
down.
like me.
I can turn it down, turn it up. Yeah.
So the context for this, folks, is I'm always struggling with lighting. My desk is in this little tiny corner. I have windows beside me and behind me, and there's a corkboard right there, and so it's forever a fight. And so I was asking Fraser how he pulls off his fabulous, even, repeatable lighting.
Yep. Okay, so check it out.
You have a box from YouTube.
I have a box from YouTube. I wonder
is
what it
your
is.
box?
Oh, I'm not gonna need that. Got a letter. Blah blah blah. Thank you, YouTube.
That is shiny.
There you go.
That is pretty cool. So that's how many followers got you that? 100,000 subscribers. That is awesome.
Yeah.
Goals.
There you go. Life goals. So I told people that I forgot to unbox it in the Weekly Space Hangout, but I figure I will unbox it in Astronomy Cast, and I'll probably unbox it during the actual Guide to Space, which is sort of where it actually happened. So, yeah, that's cool. It's pretty fun.
That is awesome.
I'm gonna say hi to some people.
Okay.
Okay. Ready? Hello to a happy coder, Adam Synergy, Aaron C, Arnold Post, Astro B, Bill K, Bert Klankar, Catalin Bontia, Colin Jones, Dusty Reichwin, Elid Avron, Eric Knapp, Eric Schneider, Fleming Thunberg, Giselle Sabrin, Gordon Dewis, Guido Bibra, Henrik Bo Anderson, Holly Meyer, Hugo Burnham, Jessica Feltz, Joanna Steinmeier, John Seffield, Jorn Albert, Kenneth Lepre, Lakshdeep, Leonard Clark, Lillian Brennan, Matt Minter, Matt Obadiah, Max Sixblade, Nancy Graziano, Navi Fairy 64, New Rules 2005, Paul Disney, Peter Quinn, R. Instro, Rachel Fry, Selena Atelier, Sylvan Westby, Tech Tang, Tony Raggett, William Vanderbeek, Yamagashi-san, and Zapfan. Hey, everybody. Welcome to this final episode
Of only the season.
of
Only the
this
season.
of Astronomy Cast. That's right. This is it for the summer. And
It's true.
and now we take the summer off. Do you know where the let's take the summer off? Do you want to know where we shamelessly stole that from?
No, where did we shamelessly
So we
steal it?
shamelessly stole that from Quirks and Quarks, which is one of my sort of Canadian staple, one
Yeah,
of my
it's
favorite.
fabulous.
Yeah, one of my favorite shows. So last Saturday, my son and I went to Hornby Island, which is my ancestral home here on the West Coast. And who happened to be giving a presentation at our local community hall?
Quirks and Quarks?
But Quirks and Quarks. Yeah, Bob McDonald, the host of Quirks and Quarks. He's actually moved to Vancouver Island, and so he loves Hornby. Came and did a lecture about gravitational waves, and it was great. And I got a chance to finally meet him in person and let him know how much the show meant to me and how much it sort of inspired my science communication. And he's down in Victoria, so hopefully we'll be able to hang out again in the future. So it's you get a chance to meet your heroes, and
Yeah.
it was awesome to be able to do that.
That sounds like a
That cool?
great day.
Yeah, it was fun.
I just want to watch the editor from Radiolab at some point, just like sit there and absorb.
Well, it's
how
Jad.
they-
Jad does it. The host
He
is the
does-
editor. Yeah. Yeah, which is I know. That's sort of his.
Dang.
Yeah, that's his technique.
He is
That's his trick.
so good.
Yeah,
Okay.
yeah. Um, okay. Let's do this thing.
We
Elad
can do
Avron
this thing.
says he wants to come to Canada someday. You totally should. Just come crash here, no problem. We got room for you. I should not have made that offer publicly. Actually, you know
I will
what?
continue to offer anyone who's driving Route 66.
Yeah.
Our new offices are on Route 66. So really stop by.
Stop by and say hi. We are because we live in such a cool place and we're starting to organize these trips. My goal was to make one be here. Like, why not why not invite a whole bunch of people here? Because it's nice here. We've got the dark skies. We've got, we can do some astrophotography here, and there's a few things to see on the island. Although some cooler things to see in the middle of the province, like the Royal Dominion Observatory. There's the chime instrument, which looks like a bunch of snowboard half pipe things. It's going to be detecting gravitational waves, primordial gravitational waves, and also fast radio bursts. It's a radio telescope. So
Okay.
yeah, super cool. Okay, let's do this thing we like to call Astronomy Cast.
Okay.
You ready?
I'm pressing record. It is recording.
I am also recording.
And we're both like on the right mic and everything.
Perfect. Here goes. Astronomy Cast, episode 454. The things we're looking forward to. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Oh, I was so close.
You got it. You did.
Yeah, I'm not going to do it again. That's fine. This is, you know what? It's just about time for summer vacation. We're about to take a break. We're a lot more laid back now. I'm not the absolute perfectionist control freak that I normally am. I'm so not a perfectionist control freak, I think is the point here. But yeah, hey, we're wrapping up another season.
We're wrapping up
a decade.
10th. Yeah.
Yeah.
Yeah. I mean, it's kind of amazing because when we met, like, your kids were tiny,
mm-hmm.
and they're now like starting to adult.
Yeah, they were 3 and 5 when you met them.
Right. And they're very much not. And our careers have gone on, and it's been an amazing 10 years. And now it's a matter of finding out just how wild is the next 10 years going to be.
Mm-hmm.
And that's the crazy part, is astronomy is revolutionizing so fast, and our technology has gotten so good that we're now at the point of what is the statistical probability, not the when will they build the tech.
Right. So before we get into the actual show part, I want to just give people an understanding of what's going to happen over the course of this summer, when we're going to be returning, and what other stuff is going to be available for them. So when we're recording this on June the 16th, this is the final episode for season 10. We will then take a break. Typically, we return after Dragon Con. We usually start our next season with whatever thing you record at Dragon Con.
But this year, we kind of have this thing called the solar eclipse.
Mm-hmm.
Where we're both going to be together. So there may be some surprise episodes coming at you out of that.
Yes. Yeah. When we did the Eclipse cruise, we did, I think, four live shows for the fans. So we'll probably do the same thing, and we'll generate a bunch of shows, and we will deliver them to you. Probably, I don't know whether we're going to do it early or whether we're going to wait till the actual season starts. We haven't figured this out yet. So
see, we need summer to plan the year, and so the planning has not yet started because it is not yet summer. But this summer, we're not only planning.
Mhm.
One of the big questions we've been getting asked is, will the Patreon office hours continue through the summer? And the answer is yes.
Okay.
There will be a 1-week break and 2 weekends while I am in the Netherlands to attend an astronomy conference. But other than when I'm in a foreign country, we're going to keep going pretty much once a week. And, well, I'm going to be working on plotting things, planning things, building things, and sharing that with our patrons for about an hour a week.
Perfect. And we've got 2 more episodes of the Weekly Space Hangout. And so we'll be wrapping that up at the end of the month. We're still going to be releasing the Guide to Space and a lot of the other stuff that we're doing over on my YouTube channel. Obviously, Universe Today will continue. No rest for the wicked. But then, we use this summer to organize and refresh and come back at the end of the summer with lots of new content into season 11. So that's going to be exciting. All right, well, let's now we may begin. As we wrap up season 10 of Astronomy Cast, we look forward to all the instruments, missions, and science results that we're looking forward to. Who wrote this? I think astronomy is exciting already. Just you wait. Beep, 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 beep.
I meant to hit mute. I missed. Okay, it's now muted.
Okay. Where do you want to... So I guess the point of this episode is, both of us... Well, as a reporter, I am looking at all of the new missions that are upcoming, all the new instruments, and we do a lot of stories about this because I always get so excited about what the future holds. But you actually worked on the decadal survey, right? So you actually helped plan some of the missions and instruments and technologies that are going to be coming out, right?
It's true. And I think the big things we have...
You muted. I can't hear you.
Sorry. So I think the big thing we have to look forward to is twofold, but I need to stress this is me speaking as human being who is an academic who worked as a human being on the decadal survey, not as representative of NASA. So all the caveats in play. These are my personal opinions, my personal professional opinions. Okay. So I think the 2 coolest things we have in the field of astronomy coming down the pipeline are the James Webb Space Telescope and then WFIRST. And WFIRST is going out there to try and figure out what the expletive dark matter is. And this is a question that we don't even really have a good beginning to. Sorry. Go
Dark
out
energy.
and find out what dark energy is. So let me start over.
Yeah. You're muted again.
Moving my mouse. I'm talking.
Muted again.
Okay. Mouse is now out of reach. Okay. Sorry, chat. So speaking as an individual, I think the 2 missions are WFIRST and James Webb Space Telescope. WFIRST is going to try and figure out what dark energy is. And this is something where, unlike dark matter, we don't even have a beginning point for. Dark matter, we know it's stuff, we know it just doesn't like the electromagnetic force. Dark energy, we don't know if it's a pressure, a force, an underlying field, we don't know. And WFIRST is going to work to, in detail, map out its effects and start giving us the kinds of clues that we got, for instance, from gravitational microlensing about dark matter, the kinds of clues that at least allow us to figure out what domain of physics dark energy belongs to. Now, beyond that, with the James Webb Space Telescope, unlike WFIRST, it is a completely flexible instrument. It is something that is going to allow people to apply for different kinds of time, to do different kinds of science. And it's going to allow us to get at both what are better images of planets right up next to their stars, as well as what was the formation process of galaxies in the first hundreds of thousands and million years of our universe. So this combination of being able to see small in the infrared, and by small I mean small angular resolutions in the infrared, is going to start to give us amazing insights across a whole variety of different aspects of astrophysics.
Now, back in the day when this was first proposed, I think it was called the Joint Dark Energy Mission, and so that was really gave you a really good sense. Now it's the Wide Field Infrared Survey Telescope, so that gives you a much better sense of what spectrum it's going to be directing at this wide field infrared. How compare this? Is this a super telescope?
It's not so much a super telescope as it kind of like WMAP, the W's being coincidental. It's a highly focused mission that is aimed at solving a single problem. And if you're like me, you have a variety of tools in your kitchen that you can use for all sorts of different things. But then you have that one potato peeler. And that one potato peeler sure does a whole lot better at peeling potatoes than any of the knives you have. And by being this highly focused mission with one goal, just like WMAP was able to so effectively map out the cosmic microwave background, just like Planck was able to follow up on and do the same thing at even higher resolutions, because it was, again, a highly focused mission. WFIRST, with its highly focused goal, its tight mission direction, should be able to get us the kinds of answers we need to at least have that starting point.
Okay, so you talked about WFIRST, and then the other one, of course, is James Webb, which is launching next year.
We hope.
Yeah, we hope.
So beyond these, then...
Do you want to just tell people? I mean, I'm sure people know what James Webb is going to do, but you might want to mention briefly what its job is.
So James Webb, as I said, it's an infrared telescope. It can see at high resolutions very faint objects, which means that it can look at a variety of different scientifically interesting things, whether it be exoplanets or stars and galaxies forming at the beginning of the universe. Now, this is a telescope that is big, and it's going to sit out beyond the moon. And so it's all on track. But as I've said many times in this show before, spacecraft are dead to me until they're actually launched and working. And so there's always the question of what happens if somebody's rockets end up getting grounded or something like that. So those are the kinds of problems that we...
You're breaking all your rules today, aren't you? We're talking about all these future missions.
Yes. We're talking about missions that, as I said, are dead to me until they actually launch.
Interesting. You're starting to crack.
Well, yeah, it happens. So beyond this, we have continued exploration on the surface of Mars. We have continued exploration of exoplanets using spectrographs here on the Earth, using repurposed spacecraft in orbit. And the thing that has me most excited and terrified, and those emotions can be held mutually, is we're starting to hit the point technologically where we don't have to listen in radio for intelligent life. We can start looking for free oxygen and other chemical signatures of life. And we don't know if we're days, weeks, hours from making those detections.
Yeah. I mean, I love the fact that James Webb will make a lot of these the observations that Hubble tries to do using these bank shots by seeing, using a galaxy as a gravitational lens or a galaxy cluster. James Webb will just make directly. It'll just be able to just power all the way out to the edge of almost to the edge of the observable universe. So, and to be able to see these newly forming planets and stars and be able to detect the atmospheres of worlds. It should be a phenomenal instrument. What else have you got?
So beyond that, it starts to be, what questions are we able to start answering? There's certain science that in the 10 years we've been doing this, we can pretty much bet any particular AAS meeting conference is going to have a press release on. There's always that new partially tidally disrupted dwarf galaxy. There's always that new idea on why is the corona so hot on the sun. There's always that press release on planet like the Earth that was found that's really nothing like the Earth. I'm really hoping we start. Well, we're always going to keep having new shredded galaxies being discovered. That's okay. We'll let those go. But I'm really hoping that we finally get that answer everyone agrees on why is the corona so hot, and that we start getting actual Earth-like planets being found with the right mass, the right distance, the right measurable atmosphere. And maybe someone comes up with a theory of planetary formation that actually like works and people agree on.
So less of a specific mission, but also just like a you think that theory is around the corner.
I want scientific consensus.
So then let's talk about here's what I am really excited about. There's two things I'm really excited about. One is the Event Horizon Telescope, which is this worldwide collection of radio observatories, has taken their image. And so its job is going to be to take an image, the direct observation of the black hole at the heart of the Milky Way's supermassive black hole. It has directly imaged the event horizon of this. And the part that's kind of hilarious is they've had telescopes all around the whole world to do it, but we have to wait until October for the data because of the data from Antarctica. So they have to wait for Antarctica's summer before they can actually get the scientists out and get the data out and get it to, and then normalize it with all of the other data that was taken around the world, which is pretty awesome. So they couldn't show the picture until they got the information out of Antarctica. So in October, we should see the first images of a black hole event horizon.
It hadn't occurred to me that they couldn't just FTP data from Antarctica.
Not that much data. Yeah, it's that. So people are wondering, like, why, they took the picture, why can't we see the image? It's because they haven't got the data from Antarctica yet.
I just assumed it's hard to combine that much data. One of my very first paid jobs was actually, part of it was finding fringes in very large baseline array sets of data. And there were common things like country X never has their timing right. And so we knew that if things didn't line up in the wave patterns, it was probably country X where the clock was bad. And it took significant time to align all of the wavelengths to get that amazing interferometric image set. So once we have the data from Antarctica, they still have to do all of their fringe finding and everything. Oh dear, these poor scientists must be going crazy.
Yeah, exactly. What else are you excited about?
At a certain point, what starts to excite me is the fact that the universe keeps surprising me. And it's things like all the worlds we keep finding underwater oceans on. And I'm really hoping that as we move to having the Europa Clipper get built, launched, hopefully get there safely, that we'll learn even more about that mysterious rogue hotspot that we just learned about. That as we keep learning more about extremophiles and uncovering more lava tubes on Mars and uncovering more about water on Mars. When we started recording the show, it was not yet completely accepted that Mars once had water.
Yeah.
And in our next 10 years, we could go to finding reservoirs, frozen reservoirs, but reservoirs on Mars. And I want to know the rest of that story. I want to know what surprises and twists are in that story. It's sort of like when you're reading a really good book and you know the author is going to do something unexpected. Like Scott Sigler books do this to me on a regular basis. And you know some things didn't go terribly, terribly sideways. Well, that's the story the universe keeps telling us. We weren't expecting dark energy. We weren't expecting oceans on moons other than Europa, but they're there. And I want to see what twists the science story has to tell.
Now, for people who follow what I do, I would say the mission or telescope that I'm most excited about is the Large Synoptic Survey Telescope, which is going to be a ground-based telescope. They actually just broke ground just in the last couple of weeks down in Chile, and it is a monster. But what is kind of amazing about it is that it will essentially survey the entire night sky that it can see every couple of nights at a very high degree of resolution. So it's going to be like the Sloan Digital Sky Survey, which is this sort of full view of the entire night sky or that the telescopes can see. But at the same time, it's going to do this every couple of days. And what it's going to do is it's going to show us how the universe is changing night after night after night. And so it's going to turn up asteroids and comets and supernovae and micro lensing events and just all kinds of things that and back to what you said, right? These things that we didn't even know were happening. You know, when it's by watching everything all at the same time is when you discover these events that you weren't expecting. And so this telescope really scratches that itch for me, which is just everything, everywhere, all the time, and then watch for anything to change.
And I have to admit, there's so many other telescopes going on. So LSST actually had their groundbreaking a couple of years ago. So now I'm trying to figure out what telescope actually had the most recent groundbreaking, because
the 30 meter, I think, or
so was it actually the extremely large telescope that had?
We just covered this on Universe Today, and I don't remember. Like I literally just I will find it. You keep working, and I will. You keep talking, and I will find it.
And this is the thing: is science is advancing so fast, and nations are starting to, in some places, withdraw the funding. And this is where it's so sad to watch, like the Gemini telescopes, because they've been struggling with their funding situation with their UK partners. But at the same time, the European Southern Observatory is sinking a great deal of resources into building a new, extremely large telescope. There is a consortium that is working to build a 30-meter telescope. It was originally scheduled to be on Hawaii. It looks like it's probably going to get moved, possibly to the Canary Islands. And so we have this case where, when I first started as a professional, there was the Soviet 6-meter telescope. There were a handful of 4-meter telescopes. Adaptive optics were brand new. By the time I finished graduate school, we were starting to build 8-meter telescopes. And then there was the special and weird Hobby Eberly telescope that only uses part of the mirror, but its mirror was the biggest in the world for a little while. And now we're starting to look at like tens of meters.
Yes.
And this starts allowing us to get the kind of light gathering power that allows us to do spectroscopy, which doesn't require the same high resolution as imaging, but starts to allow us to do spectroscopy on amazingly faint objects. It also, because we are using adaptive optics, it does start to give us the ability to do what Hubble's doing, but looking at things that are significantly fainter.
Right. So we ran a series. Now we actually did an episode of Astronomy Cast about, like, fairly early on, actually, that we called The Rise of the Super Telescopes, and we talked about a lot of these missions. I resurrected that concept over on Universe Today, and Evan Goff, one of our writers, ran through the news series. So we put in the Giant Magellan Telescope, the Overwhelmingly Large Telescope, the 30-meter telescope, the European Extremely Large Telescope, the Large Synoptic Survey Telescope, the James Webb, the Wide Field Infrared Survey Telescope, and we just added the LUVOIR Telescope.
I don't know that one.
What? Oh my God! So we had the director of it on the Weekly Space Hangout a couple of weeks ago, Brad Peterson. But it's a mind-bending observatory. So this telescope is going to be now there's by no means certain, but it's possible that it will be positioned out maybe at the Earth Moon L1 Lagrange point.
Okay.
So it'll be sort of at where the Deep Space Gateway is going to be,
Yeah.
right? And then it will be a 16-meter visible light telescope, space, right? So the center, the opening at the middle of the telescope, you could fly the Hubble Space Telescope through it, the whole spacecraft. So 16 meters. Now, keep in mind, the Hubble Space Telescope, I think, is 2.6 meters.
It's the size of a school bus.
Yeah, so this thing will be an absolute just monster, and to sort of take like that, and so we're looking at probably the end of 2020 into the 2030s before this thing actually gets built, if this is what gets built. So, but this will be the true spiritual successor to Hubble, that monster space telescope that we've always known we deserved.
Now, what data set are you most looking forward to?
Well, the LSST is the one. Well, okay, so there's two, right? One is the LSST, and then the other one is this new search that's going on for primordial gravitational waves. So we had that almost discovery of them a couple of years ago in the BICEP 2 research, and then it was overturned by the Planck research. But the thing is, the two instruments go at different frequencies. So now everyone's gone back to the drawing board, and they've developed a multi-frequency analysis, really, really detailed, to go after this question. And so within the next couple of years, we're going to see from probably 4 or 5 different separate experiments, all looking for primordial gravitational waves at all these different frequencies. And if so, then the evidence for inflation becomes overwhelming. And that's amazing if that happens. It's Nobel Prizes all around, especially Alan Guth.
I hope so. He really deserves one. He's done a lot of really good stuff over his life, and just needs the right set of people to take data, and then write nominating letters. But
what about you?
For me, exoplanets, it's completely unrelated to any of my research topics, but the diversity of worlds that are being found is so contrary to everything that we expected, that the Gaia data set and its ability to do astrometry, its ability to map out what are the closest stars, what is the actual distance to Cepheids and Aurolaris, so that we can actually get better error bars on this first rung of our ladder. The Gaia spacecraft, which is already up there, it is not dead to me.
Yes.
It is a living, breathing spacecraft. Its data set is going to give us a sense of where things are and how they're moving in our nearby universe, and give us this picture of our place in space, and this picture of where are their transits, where are their exoplanets, that just the diversity of science that we already know will come out of the data. And then you start realizing that people are going to find even newer things, better ideas, more creative ways to use the data. This is one of those data sets where I can't wait to see all the publications and see how different it changes our perspective on where we are.
Now, we're going to diverge here. So I totally agree with you, by the way. I do not disagree with you about the upcoming catalogs of exosolar planets. I can't wait. But let's talk about gravitational waves.
So, okay, LIGO is starting to pay for itself. It's now found, 5 waves? 3. Okay, maybe it's sort of starting to pay for itself.
Come on. Oh, you grump.
I am a grump. Yeah. It's a huge sum of money for 3 detections.
Yep. So,
I'm a grump.
But do you not feel that the ability or the next generation of gravitational wave discoveries is pretty exciting because it gives us a whole new sense to be able to see the universe.
So I have very, very mixed emotions here. And the reason I have such mixed emotions is we have all these other ways of seeing that, yes, gravity waves, they plunk, fill in the space, they will go here because we see the radiation of that gravitational energy in the decay of compact object orbits. There's a Nobel Prize that already went out. We have a sound theory that traces everything around gravitational waves out. And this is where the stuff that excites me is where the universe is like, nope, not going to give that to you the way you expected it. And right now, gravitational waves are just sitting there behaving nicely, fitting the theory, hopefully giving the theorists Nobel Prizes. But we haven't even given Alan Guth his Nobel Prize yet.
Well, yeah, they haven't confirmed the discovery of inflation yet. But here's the thing that, and we've got a new episode of the Guide to Space coming out, and hopefully by the time people are listening to this, they can watch the episode. But we are, once the space-based observatories go up like LISA and the Big Bang Observer Telescope, which is in development. So LISA is going to be 3 spacecraft flying in formation with like a couple of million kilometers. Their interferometer legs will be in the millions of kilometers long. The Big Bang Observer is going to be a constellation of 12 spacecraft flying in this formation. In theory, the Big Bang Observer will be able to see past the cosmic microwave background radiation right to the Big Bang directly and just look at it and look at how gravity and how masses were moving and roiling right after the Big Bang. So I think, although it's, we're now talking 20 years, 30 years out as we watch this unfold, I think that over time, as astronomers get a better sense of this, that it will turn into an incredibly productive form of inquiry into the universe. So don't write it off just yet.
So the eyebrow crimpling is, LISA is one of these missions that has always been at least 10 years off. And when I say that, I'm going back to like the 90s.
Yes.
And it's currently proposed to have a launch date of no earlier than 2030. And it's proposed to have an arm length between the spacecraft that is the same as the distance between the Earth and the Sun.
Mm-hmm. No.
And yeah, semi-major axis 1 AU. That's the current proposal.
I believe that's its orbit.
Okay.
It's 2.5 million. I think it's 2.5 million kilometers. But,
okay. Anyways, the diagram actually. Okay, I'm going to move on.
Right. Let's move on.
Not try and read things in detail while we're talking.
Yes.
And.
But anyway, let's move on to what you're excited about. You know what? Don't worry. I made my case.
Yeah.
We'll move on to what you're excited about. And we're so anything else that you're stoked about? Mars 2020 rover, the Phoebe, the mission to go after that metal asteroid, another potential flyby of Pluto, and maybe even a lander if Alan Stern gets his greatest wish.
I don't think that will happen in 10 years, though, because the travel time.
The TESS mission is going to be launching.
And don't forget about high energy astrophysics, the ground-based guys who are doing the detections where we see the neutrino detectors getting upgraded, the dark matter detectors getting upgraded, CERN getting upgraded.
Yeah, Large Hadron Collider with more power.
I want to know what dark matter is.
Yes.
I want specificity that is studied in a particle physics book. I want to know the mass. I want to know the different types. I want my happy little standard model like grid of characteristics that lets me know how it fits into the grand picture. I want details, universe.
And then, of course, just this revolution in spaceflight. what's happening with SpaceX, what's happening with Blue Origin, and even what's happening with the United Launch Alliance with some of their interesting modifications to their system. All of the rocketry companies are bringing down their costs. They're developing new techniques and technologies, and if by the end, over the course of the next 10 years, there could be humans on Mars if Elon Musk's schedule works out, which I don't think it will. But if it does, 2024 is, 100 people sent to Mars. No.
Here's the open quandary. When we recorded our first season, that was the same year that Scaled Composite won the Ansari X Prize. And Burt Rutan did his launch twice in a very short period of time. And we thought we were 3 years away from commercial space flight.
Yeah.
It's been 10 years.
Shall we now watch videos of rockets landing again on their launch pad? Is that what's required right now
So my question is not, is Elon Musk going to stop doing truly awesome things? But my question is, are we going to get FAA certification that allows commercial humans to take off from the United States of America or someplace else Elon Musk is going to launch from, or Sierra Nevada, or Virgin Galactic? Are they going to be able to start using Spaceport America in New Mexico to launch very rich people into space on their own terms?
Well,
in the next 10 years.
If they don't, Blue Origin will. So there's someone's going to be going on a trip to suborbital flight.
I really hope that we get there for regular continued journeys instead of just the handful that have flown with the Soviets. Russians, they switched nations in the process.
Parker Solar Probe launching next year to fly really close to the sun.
Yes.
That's exciting.
Yes.
We're going to explore all the things. I think the point is that we're going to explore all the things. We're going to go all the places. We're going to see all the stuff. And we hope that you all stick around with us as we get to experience this. As more and more missions become undead to Pamela as they launch and start producing science results, and we can do shows on them.
I think that sounds amazing.
All right. Well, here's to 10 more years at least. And Pamela and everybody, we will see you in September.
See you all in the spring.
Some
Fall.
We will see you in August when the eclipse happens. But the rest of you will see you in September. All right. Thanks, everybody. And we'll see you all when we're back.
And Chad, I am so sorry for the editing I just caused you. There's massive storms roiling in, which kept distracting me because I'm like, please don't let the power go out. Please don't let the power go out. And I'm sorry, Chad. I'm sorry.
I didn't hear anything in the background, so I think you're all right.
Yeah, the mic I adjusted, but there's like downpour and thunder and lightning, and I was distracted by the universe trying to kill us and hoping that the power wouldn't go out.
We've had storms here too. It's actually been really crazy. We've got a bunch of our gardens all growing, and then this big storm came through, and all this heavy wind and rain came in, and just everything's knocked over. So
I have to restake all my tomatoes.
Oh no!
Luckily they're vines, so they're pretty tolerant. So this is 454?
Yeah.
Okay. And I have a critter that keeps digging up my strawberry plants and stealing the entirety of the plant.
How is that not your groundhog?
It's probably the groundhog, but it seems to be happening in the middle of the night, so it could also be a raccoon. We have raccoons because I hear them waging civil war on a regular basis.
We have raccoons in our backyard too, and our dog went out and got in a big fight a couple of weeks ago. And
oh no!
Yeah, and so she has a big cut on her nose from tussling with a raccoon, but that was it. So she wasn't.
Oh no, so we have multiple gangs of raccoons and they move like gangs. It's kind of West Side Story. And they when two gangs come upon one another at a food source, you can hear the ruckus
Mm.
and it's terrifying.
Let's go.
Okay.
13 minutes for your questions. Lillian Brennan says the raccoons are building their own garden.
One strawberry plant at a time, apparently.
Colin Jones.
People are giving me
What?
okay.
Oh, Colin Jones is asking, is there a possibility that gravity waves could appear before the CMB? So I mentioned that in the show that in theory, right, gravitational waves were there, the primordial gravitational waves, and just there was 300,000 years of mass moving around. And in theory, with a sensitive enough instrument, you should be able to see beyond the CMB, right?
And this is one of those things where I've heard people give talks on the no, it can't be done. I've heard people give me talks that were less enthusiastic and convincing, but I don't know how much of that was a science problem versus a charisma problem. And so I'm extremely torn at this point and need to be doing more reading to understand.
Okay. Well, like I said, I'm going to have a video coming out probably later on today. So just go ahead and watch that. Because we're going to be talking, there's going to be primordial gravitational waves that we're going to be seeing like black holes moving like boats in the ocean. We're going to see the less massive black holes coming together. We're going to be seeing the more massive black holes coming together. We're going to be seeing neutron stars coming together. There is just a whole.
But the question is, can we, in a meaningful way, perceive the interacting gravitational waves and their wave structure from before the CMB?
Right, and that is the purpose of the Big Bang Observer. But as you said, right, that is the follow-on mission to LISA, which is now pushed back into the end of the 2020s. So the chances that we're going to see them. David Chung is saying an article on Gizmodo today about looking for alien megastructures around pulsars. Why pulsars? I couldn't understand that article. I haven't even read the article, but why don't we just
So I know why you would look around pulsars.
Yeah.
So the reason to look around pulsars is the pulsar itself, with its quick timing, provides a super sensitive way to look for minor variations due to the gravitational interaction with other objects. The very first planet-like things, and I say that because they were whatever survived the formation of the pulsar. The first pulsar, the first planet-like things that were ever discovered were discovered in 91 around a pulsar. And with that added sensitivity, it starts to become possible to find research stations potentially orbiting around pulsars. And pulsars are also a natural GPS system, if you want to think about it that way, where looking around space, an easy way to navigate is to have maps of pulsars that you use. Beyond our galaxy, you want to start using distant quasars, but within the galaxy, you can use pulsars. And it seems natural to start building things next to our gravitational markers. Why not? Or our navigation markers, rather.
Mm-hmm. So not much to say. Yeah, I mean, any pulsars are so regular that it's relatively straightforward to find anything that's interacting with them. As you said, they've found planets with less than the mass of Pluto around pulsars because they're just they change the light come. The pulsar's light is so dependable that you can detect it.
And the other thing is, unlike a lot of trying to detect aliens science that's going on,
I heard that.
Yeah, it's getting closer.
Wow.
Unlike a lot of the trying to detect aliens research that's going on, these kinds of studies of pulsars have a lot of other science that comes out of them. And so this ability to look for alien megastructures, which is something, how do you convince Congress that's in the national interest to do? And we know actually anyone who gets federal funding, it's now written into like national policy that we have to explain how our research benefits the nation. I don't know how finding alien megastructures benefits the nation.
Yeah.
But a lot of the science that we're doing, it's relativity based. It's easier to make a case for. So if you can do both at once,
Yeah.
it's easier to get your funding out there.
There's been some interesting surveys already done looking for both Dyson spheres, megastructures, both in terms of how they block the light of the star, but also essentially a star that is surrounded by a Dyson sphere would give off a very specific heat signature in the infrared.
Yeah.
But also people have done surveys for type 3 civilizations, so the ones that have turned their entire galaxy into Dyson spheres, that whole galaxy would give off an infrared signature that you couldn't really explain it except, that a civilization had done that. And so far, they've surveyed for tens of thousands of galaxies, and none have turned up.
And this is another one of those cases where I'm going to recommend a science fiction book. I think I've probably recommended it 5 or 6 times already, but the Bobverse series that starts with I am Legion, I am Bob. The Bobverse series actually has the Bobs encountering a massive alien civilization that has hit the point in their evolution where they're simply like mowing over solar systems and strip mining them for resources. And because it's an alien civilization that works like a hive mind, and I can't say anything else without giving away spoilers, but basically they're out there just going to eat all of this, kind of like the bunnies in Australia, and there's just nothing left.
Antifusion is saying, would you test rotating habitats artificial gravity on the moon or in orbit first?
I think it's much easier it requires less energy to build a rotating structure in orbit because you don't have to fight the gravity of the world you're on, if you think about it.
Or friction.
Yeah. So there's friction, but there's also, and I don't have any discs on my desk. So if you imagine a Frisbee, if you're on the planet and you balance it on your finger, its sides flop. And when you have it spinning, it's nice and disky. This is what happens when you throw it. Well, with a large artificial gravity structure on the moon, it's going to try and flop under the weight of gravity. And the bigger you make it, the more it's going to try and flop because the torque arm is so much longer.
Right. I mean, the idea is that you would like, say you need to give humans 1 G of gravity and the moon is providing 15% of the gravity. You're going to need to get that other 85% from this rotation. And so you could imagine something that kind of looks like a gravitron, that's
the roller coaster.
Yeah, that's like turning around on the surface. It's like a centrifuge, but it's not straight sideways. It's at a bit of an angle, and so you would live on where the outward force from you turning plus the downward force from the gravity of the moon would give you the feeling that you had one full G. And so a version of that has been planned for Mars as well. So you would take the 1/3 gravity on Mars and then also run a gravity train on this big track around on Mars. And the Martians might have to live on this gravity train going around and around and around so that their bones, don't soften and their muscles don't atrophy and they don't have to be working out all the time. And if they have to go do some work, they get off the gravity train and they go out and is that like a band or something? The Gravity Train, a song? Anyway, you'd have to get off the gravity train and then go work on the Martian environment and then come back and spend the rest of your time you're sleeping and you're living constantly in motion. So yeah, just space, just set it up and spin it, and you only have to spin it, do that once, And then it'll just keep spinning forever. You look like I just blew your mind.
No, it's more a matter of so the force that you're dealing with is mv squared over r, which means that to maintain a constant force, the bigger the radius is, the faster you have to rotate. If you want to have something big enough to live and work in, you're going to need a really big radius, which means you're going to have to be going super fast. And the technological issues of doing that, so that if a rock ends up on your track, you don't derail at high velocity.
Oh, yeah.
I'm just like, so what's going to go wrong with this one? Yeah, I don't want to be on that.
Right.
So I'm all for rotating things up in zero gravity, where you have like nice happy spokes. They're coupled in the center. You have that equivalent of moving walkways where you step between walkways to accelerate to match the rotation. We've all seen that done on sci-fi. Some of us were crazy enough that as high school students, we ran the calculations as high school projects. I'm one of those high school kids
might still be.
Yeah, but I don't want to do that on the surface of a world.
So this is right. So this is the question, right? Is like everyone wants to go live on Mars, but we still don't know if we can. We just don't know, and it's the gravity. And if we can, then awesome. And if we can't, then you won't be able to live there. You won't be able to raise a family there. You won't be able to, unless you literally are spending some time in a great big Ferris wheel that just takes you around and around and around on Mars. Like just say in space, it's where we belong, is on giant rotating O'Neill colonies at the L4 and L5 points around the sun. It's what human beings were meant to do. Or, as Pamela likes, hollow out an asteroid and set it spinning. Although it's more of it seems to be that it's the metal asteroids that you really need now. Like, the rest of them are just, they don't have the material strength, right? They're just a blob.
So we don't know. I mean, a lot of the little ones that we've gone and visited do. Itokawa is a blob of rocks. Vesta is not a blob of rocks. Vesta's a bit big. I'm not sure we want to go hollowing out Vesta. So the question is, where between Vesta and Itokawa is the transition from blob of loosely held together rocks to nice solid object we can hollow out? Again, something that hopefully we will find out in the next few years.
Yeah. Yep. We don't know, but I mean, I think the key is that we need to figure out. I mean, the 1 year mission that happened with the twins to sort of figure out what microgravity did to the human body. That was a great start. Now we need to go longer, and we need, I really feel like the next thing that we need to figure out is start to develop artificial gravity in space. And I know there's plans to try and start putting stuff to attaching them to even the International Space Station, some Ferris wheel attachment that would go onto the side of the space station even, and try to sort of test that out. There was another question there that I saw that I was just going to grab. Oh, apparently it's not an episode finale without Eddie. Is Eddie kicking around?
Let me call him. He was here at the beginning of the episode destroying Post-it notes. 1 sec.
While you're looking for him, another thing I just did an episode on physics police is saying don't confuse microgravity with Mars gravity. No, I understand that. Again, we don't know whether can you have a baby? Can you gestate a baby in 1/3 Earth gravity, have that baby carried to term, give birth, and have that baby develop normally in 1/3 Earth gravity? If you can, then everything is fine. Don't worry about it. Enjoy the lower Mars gravity. If you can't, then people are going to want to fix for this. So, oh Eddie, we've got an episode coming up for the Guide to Space, and we're going to be talking about hypersleep. About suspended animation and how they use this idea of therapeutic hypothermia to sort of cool people down. And the plan is they're going to build a rotating spaceship that will have people in torpor, but it'll turn, and so they'll experience artificial gravity while they make the mission to Mars, and so they won't worry about the loss of bone mass and stuff and muscle mass. So it's an interesting idea. I really feel like if I was in charge of NASA, that would be my next priority, would be of human spaceflight. Like I wouldn't even be not Orion, not sending spacecraft past the moon, not even working on a Mars mission. I want to know if we can develop artificial gravity, because that is like a developmental technology that unlocks everything. Anyway, I'm ranting now. So
you wandered into the land of particle physics doesn't allow that, but okay.
Particle physics doesn't allow what?
Artificial gravity.
No, rotation.
Oh, that
Yeah.
kind. Sorry, I went straight to Battlestar Galactica.
No, don't be ridiculous.
And Expanse is based on the book Leviathan Wakes, which is better than the TV show.
Speaking
I binge watched the entire series last weekend.
Yeah.
Because you've been telling me how good it is, and it is good. It is good.
But you like the book better.
Yeah.
All right. That's cool. I haven't read the book, so.
Yeah, it's an entire series. It's really solid.
So I just had a conversation with the authors of Leviathan Wakes.
Cool.
On Twitter.
James Corey or somebody else?
Yeah, James S.A. Corey, which is actually two people. It's a pseudonym for two people.
I did not know that.
Yeah. Yeah, it's not one author. It's two people.
Cool.
Yeah. So that was so cool. Man. How exciting.
BarkBox toy.
Did BarkBox just get a free advertisement?
Well, they actually in the edited version will have an ad at the midpoint of the show. So today's BarkBox anyways. But this is one of the toys that we got a while back. It needs to go through the wash. But it's what he just brought me.
People are saying book is always better.
Not always.
Not always, no. Like I would say like Game of Thrones, I am fine to never read any more Game of Thrones books. I'm sorry, George R. R. Martin. I was on board early on, but the TV show is great, and I'm fine, and it tells me the story, and I'm good with that. So I don't need to read the books anymore.
Any of you who are fans of musicals, do not read the book that the musical aspects of love is based on. It is one of the worst books I've attempted to read.
But the musical's okay?
The musical's fabulous.
All right, well, let's wrap things up. Here we go. So I guess people are proposing, I will be the director of NASA. You will be the chief scientist. There we go. Perfect.
And Patreon people, if anything happens, it's because there's a massive storm out there.
Oh, you're going to do your office hours after this?
Yeah,
right,
so we have office hours in 25 minutes, assuming I still have power.
Let's hope. All right, well, I think it's time to wrap things up. Thank you once again, everyone. Thanks, Pamela. If you haven't already, join the WSH crew. That's, of course, this community down here. This is the group of people who they support each other emotionally over this long, dark summer while we don't have any of our shows. So
and me and him, they support us too.
Yes.
We love you.
Yeah,
guys.
we're in the community too. So go to wshcrew.space, join the community, and then you'll have a chance to hang out with all of your friends and all of us over the course of the summer. All right, let's wrap it up. I'm going to press the goodbye button. Goodbye.
Goodbye.